Alright guys, so today we're going to talk about integration by trigonometric substitution. So we're going to have three cases. When we have some square root, let's say, of something that looks like x squared minus 9. And let's put here, I don't know, a 3. Something like that. And here, let's say we have something of the form 9 minus x squared. So I'm gonna flip them, and maybe let's put here, and I don't want to do an x because you can do by u substitution. Maybe an x squared. How about that? And let's do here a 9 plus x squared, and let's throw in a square root nonetheless. So all of these are perfect candidates for us to do a trigonometric substitution. So the idea will be, we're always going to be using the Pythagorean theorem. So let's say we have a right triangle with an angle theta. And let's say this is C, and this is A, and this is B. So we know that C squared is going to be equal to A squared plus B squared. Okay? So we're going to be using that. Now, when you have a plus, you're in this situation here. However, in these other two situations, we have a minus. So what you want to do is look at subtracting one of these guys. So when you have minus, the first term that appears, the one you're subtracting for, has to automatically be the square root of it is going to be the hypotenuse of your triangle. So here the square root of 9, 3 is automatically going to be that because you're subtracting from it. That is going to be your larger quantity, the one you are taking from. Thus the hypotenuse. So here it's going to be x. Now, whenever you have these two situations, when you have the hypotenuse has a number, usually it's convenient to put the term that involves the x here, the square root of it. And in this case, it is convenient to put the square root of the other guy here. Now, that is not necessary. The only reason we do that is because this will give us a sine substitution. This is going to give us a secant substitution. If I were to put the x here, it would give me a cosine substitution. And if I were to put this guy here, it would give me a cosecant substitution. So whenever I would do the du for that, I would end up with a negative sign. That's why we avoid it. Alright, so now let's look at this term where you have a plus. Well, in that case, you have a choice. So you're going to have 3 and x. Both are going to be sides of the triangles, either adjacent or opposite. So what we're going to do is we're going to pick the x to go here, the one that has the x, and then take a square root here of 9, and we put the 3 here. That is going to give us a tangent type of substitution, and the derivative of the tangent is the secant squared, as opposed to if we would flip them, we would get a cosecant substitution, and you get cotangent substitution, you get negative cosecant squared. Not the answer, you'll get the answers, but it's just going to have to carry a negative sign. So why not? Why do that? Alright, so now the term that we're missing. So here, I want to compute it real quick, and then I'm going to erase it. So I have that x squared is going to be equal to this guy squared plus this guy that I don't know, b, let's say. And so if I solve for b, 9 squared, 3 squared is just 9. Sorry about that. Plus b squared. And so equals b squared. I didn't hit shift on the keyboard. So then you get that b is going to be the square root of x squared minus 9. Thank goodness I said I was going to erase it because it became a mess. But notice that this square root is going to be the last part of your triangle. So let's go ahead and erase that mess and put it down where it goes. So after computing this, we get that this is x squared minus 9. And now this one, you can guess, you can do the Pythagorean theorem to get that this is going to be the square root of 9 minus x squared. And guess what? This is going to be the square root of 9 plus x squared. Please pause the video and do the Pythagorean theorem for each one of them and solve and make sure that we are in agreement. So now with that, we will go ahead and write that x over 3 is going to be the hypotenuse over the adjacent. Now, cosine is adjacent over hypotenuse, so this is the reciprocal of cosine. What is that called? Secant. So from that you get that x is going to be 3 secant of theta, and dx will be 3 secant tangent d theta. Alright, so there's one more thing I need to be able to plug things in, and it is how in the world do I compute this square root, because I'm going to need to substitute in the square root. And now, some people just plug in the x equals 3 secant here and use identities. I don't like to do that. Instead, I do opposite over adjacent, that is the tangent. If I multiply everything times 3, or multiply the 3, so I'd have divided by 3, it gives me the tangent, so I can write it as 3 tangent. So I can now substitute everything in. Let's see, can I fit it there? Hopefully. I think I'm almost at the bottom. In any case, this is going to be the integral. I'm going to try 3 times, and instead of dx, I'm going to plug in 3 secant tangent. And now, instead of the denominator, I get 3 tangent. And so, where do things come from? This right here is this square root here. And the numerator, 3 secant tangent theta, d theta, that comes from my dx. It got a little cramped, but I wanted to show you the 3 examples in the same space. Notice that then the 3 and a 3 cancel, tangent and tangent cancels, and this gives me 3 times the integral of the secant, which is going to be 3 times natural log of the secant plus tangent, the whole thing, plus c. And I'm going to solve every one of these substitutions, and then at the end I'm going to solve the actual integrals. Just so we see in contrast how things work on each case. Alright, so here, what I'm going to do is I'm going to grab, what is the easiest thing to divide? Well, opposite over hypotenuse. What is that? That's going to be a sine. So x over 3 equals sine of theta, from where I get that x is 3 sine of theta. So then dx, you take your derivative, is 3 cosine theta. You see, that's why I didn't want the cosine here, because then my derivative, I don't have to have extra negative signs. And then when I do adjacent over hypotenuse is the cosine. So square root of 9 minus x squared over 3 is going to be the cosine. Let me multiply 3 on both sides and I get that. So I can substitute everything into my integral, and somebody didn't write dx. Okay, well, that was ugly. So when I square this one, I get 9 sine squared of theta. The dx gives me a 3 cosine of theta d theta. And the square root of 9 minus x squared gives me a 3 cosine of theta. And so that cancels. I think I'm too low. I hope I fit it. The 3 cancels, the cosine cancels, and it gives me 9 sine squared d theta. This is one that you'll have to compute with the half angle formula. But again, this integral of the secant, you know it from tables or just from calculations we've done in the past, which is natural log of secant plus tangent. Now the sine square, you have to do half angle formula and write it as 1 minus cosine of 2 theta over 2. Then you can solve it. And the last one is going to be this one we're going to do here. So again, I want to do x divided by 3. That's the easiest one to do. that is going to give me a tangent. Opposite over adjacent is a tangent. Let me just write x equals 3 tangent by multiplying 3 on both sides. I don't know if the theta fit very, very tight there. Dx is going to be 3 secant squared of theta d theta. And now I need the square root. The square root, I want to do square root divided by 3. That is hypotenuse over adjacent. That is going to be the reciprocal of the cosine, which is secant. So my square root of 9 plus x squared is going to be 3 secant of theta. I don't even know. I don't think that fit there. Anyways, now we can substitute things in, and I get the integral of dx, which is 3 secant squared of theta d theta. That is my dx, over the square root, which is 3 secant theta. Apparently I like the integral of the secant because it appeared twice today. 3 secant, 1 secant in the numerator cancelled with 1 secant in the denominator, and I got 3 different integrals that I will solve, and these 3 integrals, well, 2 really, because 2 are going to be the secant of theta. So I'm going to have to try to remember all this, and then I'm going to erase and finish each one of the integrals. Alright, so I'll be right back. Alright, so let's continue with this one. After getting a little bit messy, we ended up at the integral of 3 times the secant of theta d theta. And as I had said, this is 3 times the natural log of the absolute value of the secant of theta plus tangent of theta plus c. Remember, plus c all the time. Now, I have to take back my substitution. But I already have that the secant from this formula here, secant is x over 3. Now, the tangent I also have here from the triangle, and that's the advantage of just writing everything for the triangle. Then you don't have to worry about trying to figure out these things. You already have them from the beginning. So when I plug it in here, I get 3 times the natural log of the absolute value of x over 3. Let me factor a 1/3 out of that, because we're going to separate it out and cancel it anyways. And x plus the square root, so x from the secant, and the square root of x squared minus 9 from the tangent. Plus c, don't forget. And now what I'm going to do is, you see this 1/3, you can separate it into natural log of 1/3 and plus natural log of this absolute value of x plus root of x squared minus 9 plus c. Well, I forgot my 3, I guess. I was not intending on writing the whole thing. I ended up writing it anyways. But this natural log of 1/3, you can move it and absorb it into the constant. So you can just rewrite this as 3 natural log of the absolute value of x plus square root of x squared minus 9 plus c. And that looks a lot nicer. You could cube it if you will, if you want, but that's good enough as it is. So we finished this one. Let me erase everything, rewrite what we had for the other one, and I'll be right back. Alright, so this is where we had stopped this one. We had done our substitution, we ended up here, and I told you, whoops, wrong marker. I told you do a half angle formula, so 9, and then integral of 1 minus cosine of 2 theta all over 2 d theta. So you can pull out a 9/2, the integral of d theta minus 9/2 again, the integral of the cosine of 2 theta d theta. Now, the first one is just a theta. That's that, because you're just integrating this one. Now here you need a u substitution. So you're going to make this guy your u equals 2 theta. du is going to be 2d theta. So you're going to have to divide by 2 whenever you do your whole substitution. Please go ahead and pause the video, do your u substitution, and make sure that you get this 9/4 of the sine of 2 theta. And then plus c. Alright, so now, did you get the right answer? I hope so. If not, just shoot me a message in the comments and I create a video on U substitution, if you will. And now I'm going to substitute in here my 9/4 with a 2 times sine of theta times cosine theta plus c. That's the identity that tells you that the sine of 2 theta is 2 times the sine and the 2 times the sine and the cosine times the cosine. And we get 9/2 of theta. Now let's solve theta from here. So I have x over 3 is sine of theta. So the arcsine of x over 3 is equal to theta. So I can substitute in just taking arcsine on both sides. So I get 9/2 of the arcsine of x over 3 for this one. Now here I get a 9/2 of sine times cosine. So minus 9/2, canceling the 2 and the 4, sine. Now sine is x over 3. Cosine, from here I can write it as square root of 9 minus x squared over 3. Plus c. And now you can cancel, by the way. You just get 1/2 because this cancels with this 2. And you get 1/2 of x times the square root of 9 minus x squared. But I'm very, very close to the bottom. I think I barely fit it, I think. So we're going to leave that one at that. So I'm going to erase the last one and we'll wrap the video up there. Hopefully this all made sense and you could compare and contrast the sine, tangent, and secant substitution. So I'm going to erase and I'll be right back. Alright, so this is where we left this one off. And we had to do now the integral of the secant, which was the natural log of the absolute value of the secant plus tangent plus c. And now from here we have that x over 3 is the tangent. You kind of see what's going to happen. I'm going to swap them because I computed the tangent first, but it's an addition, it's commutative, no worries. Now here the secant is going to be the square root of 9 plus x squared over 3. Plus c. I'm going to factor a 1/3, separate it out, absorb it into the constant. You don't need to do this, but sometimes if you check the answer in the back of your book, it's going to look simplified like this. So it's good to know where it comes from, even if you don't want to do that. That c became ugly. Oh, it was nice. Now it's, I don't know what it is. Alright, anyways, that is the answer. So I'm going to stop right here. This was a good video already. Thank you for watching. Thank you for sticking to the end, and I'll see you in the next one.